Okay, you would have had some time now to fill out those sheets or those questions, and I'm only going to go over really about three of the questions, four of the questions, so that we have answers to them from the liquid density experiment. And the one is on the first page, and it says, why does the red food coloring disperse more quickly through the water than the blue? And this helps us explain why what happened here happens. And what it is when the red food coloring is put in to the hot water, the particles in the hot water are moving very, very quickly. And as they move quickly, they bounce off each other and they create more space between each particle. And the space that's created allows the red food coloring to disperse quickly throughout the water, right? Because it's not knocking into these particles of H2O. Okay, so as it's moving faster, it allows it to disperse quickly. Vice versa, in the cold water, think about as it's getting colder, it's becoming ice. It's becoming more closer to a solid than it is to a liquid or a gas. So in the cold water, think about it when you're cold in the winter. You want to just kind of bundle up and you're slow. You don't want to get out of bed. You want to just kind of lounge around with a blanket around you to stay warm. So the colder moving, the colder water creates slower moving particles that tend to huddle up together to try and stay warm, if you will. But because those particles are so close together, the blue food coloring has to go around them slowly just to get throughout the entire jar of water. Okay, so that's what results there. And going to the backside for the question, you have to answer the question on what results did you expect, why or why not. All right, but explain the science behind this experiment. Well, the science is what we kind of just explained. In the hot water, since the particles are moving much quicker, they are less dense than in the cold water. So that's why we can see that the hot water is able to stay afloat over the cold water. The slower moving particles keep that cold water at the bottom. Think about it if you go into a pool, early in the spring. If it's a real sunny day, the top of the water might be nice and warm, but you go in deeper, you go into the water, your feet get cold. That's because the water at the bottom hasn't warmed up yet. It hasn't. The warm water hasn't, or the warm particles haven't been able to disperse throughout the whole pool, so that the bottom is colder than the top. All right, it separates itself. So when the particles are slower moving, they're closer together, they're more dense. So that's why they stay down towards the bottom. That's why when we had the cold water over top of the hot water, the cold water particles wanted to move to the bottom and the hot water wanted to move to the top. They're less dense, considered more dense. That's why this one mixed and this one, they stayed separate. The hot water is less dense and stays on top of the cold water that's more dense. There's the science behind it. You can also think of I use the analogy of a basketball team, basketball court. All right, think about the density in this way. The cold water would be like playing defense on a basketball court. You want to compact the team in so that it's tougher for them to get to the basket. You want to compact everybody around the basket so that the offense can't get in there. What the offense wants to do, the hot water, they want to spread out the ball. They want to spread the court out so that the defense ends up moving and they got more space to work with. Okay, so hot water is like the offense spreading around, fast moving. Defense, the cold water is like the defense, slow moving, staying compact. Density is about the compactness of an object or matter. Okay, what conclusions can you draw from the experiment? Well, I think we just kind of went over them. You can conclude that, faster moving particles in liquid are going to be less dense than slower moving particles of a liquid. So a slower moving liquid will be more dense. All right, the particles aren't moving as quickly. Okay, some other examples that might result in something like this. The one I always think about is oil and water. All right, oil and water don't mix. Oil sits on top of the water. All right, this would be oil, this would be water. So if you have a grease fire in your kitchen, you never want to use water because all the water is going to do is spread that oil out and create a bigger fire. Think about the Exxon Valdez, for your parents might remember that out in Alaska. For you guys down in the Gulf, the BP oil spill where it came the oil came up from down deep in the water. You had that leak. Oil came up to the surface and kind of stayed on the surface. It's less dense than water, so the oil floated up and stayed on the surface, can cause the problems. Think of some other ones and give your teachers maybe an idea of some other examples that you can think of on that subject. I hope you enjoyed today's experiment. I enjoyed certainly doing this, and I hope you had a good time and got a better understanding of density. Any questions, you can ask your teachers, or you can certainly try and get in touch with me. I'd be more than happy to help out. I hope you enjoyed it, and I will see you soon. Take care.